Okay, so I made a bit of a mistake when I was talking about uh the limiting behavior of these functions for v of t and y of t when we're talking about uh the drag force being equal to negative b times v. So when I was talking about this function, I said that 1 minus e to the negative b over mt was going to approach 0 as t went to infinity. What I should have said was that uh, at t equals 0, 1 minus e to the negative b minus m times 0 is 1 to the negative e to the 0, which is 1 minus 1. So at that point, uh, v of t is equal to 0. And then as time goes on, e to the negative b over mt goes to 0, not 1 minus e to the negative b over mt goes to 0. So this approaches negative mg over b, which is the terminal velocity, uh, v terminal. So when I was talking about y of t, I think that I got all of the math right, but again, I said that as t goes to infinity, 1 minus e to the negative b over m goes to t goes to 0, when really 1 minus e to the negative b over mt goes to 1. So what this means is that as time goes to infinity, uh, it basically the y of t begins to approach the line m squared g over b squared minus v terminal t. Uh, so it approaches that line, but instead of it just being negative v terminal t, some it is offset by that m squared g over b squared as the y-intercept. So the reason that that happens is that uh, if there were no, if it wasn't any time, if it didn't take any time to accelerate up to the terminal velocity, and it was just following the terminal velocity, then would just be negative mg over bt. But the time that it takes to accelerate to terminal velocity essentially adds a y-intercept m squared g over b squared. That means that it's always going to be some uh, delta y, some m squared g over b squared higher than it would be if it was just falling from y-intercept, or falling from v terminal at a constant speed the entire time. So what this looks like, I think, is this solid line in the y of t graph, which is approaching the dashed line, which is our limiting factor. So I couldn't get I couldn't get Wolfram Alpha to make like a satisfying graph of this for me. But I believe, based on my intuition, that that's going to be what it looks like as time does go to infinity. It begins to look linear as it approaches terminal velocity, but does have that y-intercept. Okay, that's all I have to say. That's the only major mistake I could think of. So I'm just going to leave you to this. See you on Monday.